Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for instantaneous decoding of conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today we will go through the concepts GIS applications in irrigation planning and scheduling. Now, with respect to the GIS operational framework, which is a basic tool for planning, GIS helps to optimize the irrigation system. We have to objective that to ensure efficient water distribution over the command area by the soil, crop and weather data. So the working principle behind that operational framework is analysis of soil, crop and weather data, where the spatial variability and decision support are dependent on that analysis. The characteristics of variability or variation in the soil type, crop type and weather conditions, we have to take our decision for the existing crops. So the canal alignment, crop planning or any other agricultural facilities or activities are dependent on that analysis, which reduces wastage of water, which reduces the time and which increases the productivity and efficiency. So by using that planning and development point of view, in the smart cities, GIS operational framework plays a key role for smart city development by keeping the objective to create efficient, connected urban environment. The integration of that GIS data by using the IoT tools and real-time tracking, the working of that GIS environment is utilized for the development or assigning the futuristic planning. The traffic utilities, traffic conditions, social fabric, these are all the management applications for that GIS data integration. Here in the spatial planning, we are doing the real-time monitoring. That real-time monitoring is most important for designing the policies, or we have to frame the policies. These 4M, measurement, monitoring, modeling, mapping, enhances the quality of urban life. So measurement is the basic data acquisition based on some satellite or any aerial platforms or any ground based platform or any surveying tool. We can collect the data by using various advanced technologies. In monitoring, we have to monitor the change detection of previous data in current situation or in futuristic approach based on that measurement or the data acquired. This GIS operational framework, in third phase we have to predict or we have to target our objective, or we have to select any of the objective for modeling, where simulations and prediction simultaneously work based on that monitored data, which is taking the input of the data measurement or data acquisition. At the end, by using that spatial representation of mapping, the existing data which is extracted or displayed in n number of layers, and that layers must have to be studied for the futuristic objective. So inputs are the satellite data by using some IRNSS or any type of satellite, or we can use the data by using some topo sheets or by using some field surveys. So this GIS operational framework is most important in the agricultural field, in the smart city planning, in the traffic density or any other characteristics. Now, moving towards the canal network analysis, the gravity flow, which is based on some slope, gradient or any topographical characteristics. Now, here two models are there: network model, which is a 2D vector map, and terrain model, which is a 3D digital elevation model cross section. So 2D map is a graphical representation where easting in meters on x-axis and northing in meter on y-axis. So x and y-axis comparison explains the actual network or grid by using some legends, which shows the green color is the arcs, canal segments, and orange color are the nodes that are regulators, junction points, or end points. Now that nodes are used to regulate the water flow to control the actual pressure of water which is flowing through that grid, and arcs are nothing but the canal segments or the passage of which is provided for flowing the water. These are also useful for checking the capacity of that arcs. Now in terrain model, the 3D digital elevation model cross section is there, where x axis and y axis is there, but there is a third axis of z which showing the elevation on that existing coordinates. So 3D view is a digital elevation model based on channel alignment, minimizing the earthwork through optimal gravity flow. So with respect to that gravity flow or optimum activities, we can check or we can monitor, we can study as a civil engineer that terrain characteristics. Irrigation planning is essentially a spatial optimization problem. So we have to move towards water from a source to multiple feeds, or we have to divide the existing water from the source to the existing field while minimizing the losses and ensuring equitable distribution. GIS allows us to integrate topographic data, soil maps, and climatic conditions or informations to design canal networks and drainage systems. So by using that GIS model, civil engineer use the spatial advantage, or civil engineer have the spatial advantage. We can simulate how water will flow across the landscape or the topography before a single rainfall or single water show with respect to slope and with respect to gradient, which results in more efficient layouts that reduces construction cost and long-term maintenance requirement. So designing the canal alignment is not a simple task, which is a tedious activity for a civil engineer point of view. So designing the physical path of a canal is a core civil engineering task. GIS simplifies that activity by allowing us to perform least cost path analysis on a digital elevation model. Least cost path analysis on digital elevation model. The software identifies that alignment which gives the natural contours to maintain gravity flow while avoiding obstacles like protected forest or existing settlements. For any civil engineer point of view, this digital alignment process is significantly faster than manual surveying. This allows for the immediate calculation of cut and fill volumes, which are critical for budgeting and material management during the construction activity. Owing towards command area mapping, command area means we have to utilize the existing resources for the sake of our objective, just like the water stored in a dam, and we have to use that stored water for the irrigation purpose in nearby area or in the downstream side area. So for that purpose, the GIS model is used where overlay analysis for n number of layers at the same location, land use layer, slope layer or drainage layer, canal network layer, command area layer likewise. So we have to focus the arable land for the sake of our interest, that we have to distribute the actual water stored in the dam. Here overlay analysis, which is the intersection of arable land to the canal accessibility. So we have to use the canal water from the actual water resource to the nearby command area, which results that the effective utilization of water by using the grid or the network model, and we have to satisfy the requirement of water crops in the nearby area. Here the water requirement calculation is the actual water requirement or the crop water requirement, which is one of the coefficient, into the actual area which is targeted by that GIS polygon. So we have to target the area by using GIS, satellite imagery or aerial photogrammetry. We have to multiply the coefficient of water crop requirement or the water requirement of any crop with respect to the ideal condition or the climatic condition, so that we can calculate the water requirement. So the crop water requirement analysis is most important point for the primary GIS application in irrigation, where we have to determine the actual water available and actual water requirement. By using satellite imagery to identify crop types and their growth stages, land use land cover analysis plays a main role, where the meteorological data is also targeted, just like transpiration, evapotranspiration, evaporation. So we can calculate exactly how much water is needed in each specific zone. So in GIS point of view, this is represented as a thematic map which showing the water demand across the command area. This precision prevents over irrigation, which leads to waterlogging and salinity, and under irrigation or over irrigation, which reduces the crop yields, ensuring suitable, sustainable, effective agricultural productivity. By using the satellite imagery to identify crop types and their growth stages, land use land cover analysis is used to monitor. By combining with meteorological data, we can check the evaporation or evapotranspiration, so we can calculate exactly how much water is needed in each specific zone. So in GIS, this is represented as a thematic map showing the water demand across the total command area. This precision prevents that the over irrigation, which leads to waterlogging and salinity of the soil, under irrigation, which reduces the crop yield, ensuring sustainable agricultural productivity. Smart City GIS framework, which is one of the case study point of view, we can check or monitor the example of Hyderabad city, where Hyderabad Environmental Information System model is used on the basis of GIS. Moving to the urban context, we define a smart city as one of that uses digital technology to enhance the quality of life, reduce cost, and improve sustainability. At the heart of every smart city, which is a high resolution GIS framework, a digital twin of urban environment. For any civil engineer point of view, if we are using the GIS framework to develop a smart city, it means that every asset from underground pipes to overhead street lights, from underground pipes to overhead street lights, which is recorded with its precise coordinates and real-time statistics. This geospatial foundation allows us for the seamless integration of transportation, energy, and water systems into a single manageable dashboards. So our objective is we have to monitor the urban densification and sprawl on the basis of GIS and remote sensing in three phases, where data capturing, processing that captured data, and output of that model. So in data capture, we have to utilize satellite imagery, aerial photogrammetry, or any tool for surveying or data capturing. That whole data capturing with respect to the requirement of model, we have to process that data for the geocoding objective or the topology objective or topographic objective, meteorological departmental characteristic objective. With respect to that, we can process the data and we get our objective as an outcome after the processing activity. In GIS, the urban utility and its management, its most important point based on the topographical characteristics or the topology, where managing the underground infrastructure through node link topology. So we have to study the slope, gradient, topographical characteristics to provide the grid of drinking water or the sewage water by using some arcs or node technology. Managing complex urban utilities is the most immediate application of GIS in smart cities. By integrating the GIS with SCADA, that is a supervisory control and data acquisition model, engineers can monitor water pressure, detect pipe bursts, pipe leakages, and manage electrical loads in real time scenario. If a water main or if a water pipeline breaks, the GIS can instantly identify which walls need to be closed and which customers will be affected. Significantly, this reduces emergency response time. This digital management of invisible infrastructure is what makes a city truly smart and resilient. Now, moving towards the application of smart city or the facility provided by smart city are the road and its utilization. So smart transportation and smart traffic management is most important point. Nowadays, the traffic flow analysis, which is one of the major concern in smart cities like Bangalore, Mumbai, Pune, etc. So we have to provide the path to the moving traffic in peak hours by using the optimization technique, where the persons who are traveling from a place to another place, they can travel without any huge traffic jam. So in smart cities, GIS is used to optimize transportation network by analyzing real-time GPS data, where vehicles and traffic sensors are interconnected, and they use that GIS technology for its betterment. The system can identify congestion patterns and which suggest the rerouting or another routes to the vehicle users or the drivers, or we can adjust the signal timings dynamically so that the moving traffic can ply efficiently. For transportation engineers, this data driven approach is vital for planning new public transport, new public transit, new routes planning, and assessing the impact of transit oriented development. It moves city planning from static 20-year master plans to dynamic real time adjustments which respond to the actual movement of the citizens. Nowadays, the cost is the most important factor, where we can consume a large amount of fuel and time in the traffic congestion. So we have to reduce that consumption of fuel and consumption of time by providing a continuous moving from A node to the B node or from origin to the destination. So we have to minimize the traffic congestion by providing the smart city road connectivity, and we have to utilize that road effectively for the longest path also and for the shortest path also by the segregation of traffic. Also, we have to improve the traffic flow by using the traffic signals so that we can assign a penalties to the persons who are not following the rules of traffic. And we have to minimize the traffic density by by creating the awareness among the people by using the social transportation system. What are the benefits in civil engineering, or we can say that the future of engineering based on that GIS technology or application of GIS in irrigation, in transportation, in smart city development, in urban planning, in subsurface irrigation, in agricultural department, in meteorological department. There is a huge platform is available where we can demonstrate the power of spatial data to solve global challenges, whether we are optimizing water for a village or managing the energy grid of a metropolitan cities. GIS provide the analytical framework which is needed for sustainable engineering. As we are civil engineer as a profession, we must have to find a spatial literacy is no longer optional. So it is the language of development of a modern civil engineering era. By mastering these tools like GPS, GIS, remote sensing, we can prepare ourselves to build and manage the efficient, resilient, and smart city infrastructure for the future connectivity. Stay tuned, guys. Happy learning.